The human brain is an extraordinary organ, a marvel of biological engineering that has fascinated scientists and thinkers for centuries. It is the command center of our body, controlling everything from our heartbeat to our thoughts and emotions. For centuries, scientists believed it was hardwired and fixed after childhood. This belief was rooted in the idea that the brain's structure and function were set in stone once we reached a certain age, and that any damage or loss of function was irreversible. This meant that damage was permanent and learning new skills became increasingly difficult with age. People who suffered from brain injuries or degenerative diseases were often left with little hope for recovery or improvement. However, groundbreaking research has revealed a remarkable truth. Our brains are capable of remarkable change throughout our lives. This discovery has opened up new possibilities for rehabilitation, learning, and personal growth. This ability to rewire itself, to adapt and learn, is known as neuroplasticity. Neuroplasticity is the brain's incredible capacity to reorganize itself by forming new neural connections throughout life. Imagine the brain as a bustling city with billions of neurons or brain cells, interconnected like a vast network of roads and highways. Just as a city grows and changes, so too does our brain, constantly evolving in response to new experiences and information. Every time we think, feel, or act, signals travel along these pathways, strengthening existing connections and forging new ones. This dynamic process allows us to learn new skills, adapt to new situations, and recover from injuries. This constant process of rewiring allows the brain to adapt and evolve in response to our experiences. Whether we're learning a new language, playing a musical instrument, or recovering from a stroke, our brain is continually changing and adapting. This discovery of neuroplasticity has revolutionized our understanding of the brain. It has led to new treatments and therapies for a wide range of neurological conditions, offering hope to millions of people around the world. It's no longer seen as a static organ, but rather as a dynamic, ever-changing landscape shaped by our experiences, thoughts, and actions. This new understanding has profound implications for education, mental health, and personal development. This means that we have far more control over our brain health and cognitive abilities than we ever thought possible. By engaging in activities that challenge and stimulate our brain, we can enhance our cognitive function, improve our mental health, and lead more fulfilling lives. Neuroplasticity, in its simplest form, is the brain's ability to change its structure and function in response to experience. This remarkable capability is what makes the human brain so adaptable and resilient. It allows us to grow, learn, and evolve throughout our lives, constantly reshaping itself based on the activities we engage in and the information we absorb. It's the process by which our brains develop new neural pathways, strengthen existing ones, and even reassign functions to different areas of the brain. This dynamic process is ongoing and happens at all stages of life, from childhood through adulthood and even into old age. It's a testament to the brain's incredible flexibility and its ability to adapt to new challenges and environments. This plasticity is what allows us to learn new skills, form memories, recover from injuries, and adapt to new situations throughout our lives. For instance, when a child learns to ride a bike, their brain is busy forming new connections that help them balance, pedal, and steer. Similarly, when someone recovers from a stroke, their brain can rewire itself to compensate for damaged areas, often allowing them to regain lost functions. Think of it like this: when you learn a new skill, like playing the piano, you are essentially creating and strengthening neural pathways in your brain related to music, coordination, and muscle memory. Each practice session reinforces these pathways, making the movements more fluid and the music more intuitive. Over time, what once seemed difficult becomes second nature. The more you practice, the stronger these pathways become, making it easier to play and improving your skill level. This principle applies to virtually any skill or knowledge area, whether it's learning a new language, mastering a sport, or even developing better social skills. Consistent practice and exposure lead to more robust neural connections. This process is not limited to specific skills. It encompasses a wide range of activities and experiences. From the mundane to the extraordinary, every action we take and every thought we have can contribute to the ongoing remodeling of our brain's architecture. It happens all the time, in countless ways. Whether we are learning to cook a new recipe, navigating a new city, or even just engaging in a stimulating conversation, our brains are constantly at work, adapting and evolving. This continuous process of change is what enables us to grow and thrive in an ever-changing world. Every time we learn something new, whether it's a new language, a new fact, or a new way of thinking, our brain rewires itself to accommodate this new information. This rewiring is not just a minor adjustment. It can fundamentally alter the way we perceive and interact with the world. It's a powerful reminder of the brain's incredible capacity for growth and transformation. The most evident examples of neuroplasticity are seen in our ability to learn new skills. This remarkable ability of the brain to reorganize itself by forming new neural connections is what allows us to adapt, grow, and master new tasks. Whether it's picking up a musical instrument for the first time or learning to knit, our brains are constantly evolving. From mastering a musical instrument to learning a new language, every new skill we acquire changes the physical structure of our brains. This transformation is not just superficial, it involves deep structural changes that enhance our cognitive abilities. For instance, when you practice the guitar, your brain strengthens the connections between neurons involved in motor skills and auditory processing. When we engage in repetitive practice, specific neural pathways become stronger and more efficient, making us more proficient in that skill. This is why athletes and musicians spend countless hours rehearsing the same movements or pieces. The more we practice, the more our brains optimize these pathways, leading to improved performance and mastery. This process is not limited to childhood, as once thought. While it's true that children's brains are incredibly malleable, adults also possess a significant capacity for neuroplasticity. This means that it's never too late to learn something new or to improve upon existing skills. Even in adulthood, our brains continue to rewire themselves as we learn and grow. This ongoing adaptability is crucial for maintaining cognitive health and can even help stave off age-related decline. Engaging in new learning experiences keeps our brains active and resilient. For instance, studies have shown that adults who learn to juggle experience an increase in grey matter in specific areas of the brain associated with visual and motor coordination. This increase in grey matter is a clear indicator of the brain's ability to adapt and grow in response to new challenges. This demonstrates the brain's remarkable capacity for adaptation and growth throughout life. The ability to form new neural connections and strengthen existing ones is what allows us to continue learning and adapting no matter our age. Learning a new language is another excellent example of neuroplasticity in action. When we immerse ourselves in a new language, our brains undergo significant changes to accommodate the new vocabulary, grammar, and sounds. This process not only enhances our linguistic abilities but also improves our overall cognitive function. Research has shown that multilingual individuals have increased grey matter density in areas of the brain responsible for language processing and cognitive control. This increased density is a testament to the brain's ability to adapt and grow in response to new linguistic challenges. This suggests that learning multiple languages can enhance cognitive flexibility and improve overall brain health. The benefits of neuroplasticity are vast and far-reaching, impacting not just our ability to learn new skills, but also our overall cognitive well-being. So, whether you're picking up a new hobby, learning a new language, or simply challenging your brain in new ways, remember that your brain is constantly evolving and adapting, ready to take on new challenges. One of the most inspiring examples of neuroplasticity is its role in stroke recovery. After a stroke, which occurs when blood flow to a part of the brain is interrupted, brain cells in the affected area can be damaged or die. This can lead to various disabilities depending on the area of the brain affected. However, thanks to neuroplasticity, the brain can rewire itself to compensate for the damage. Healthy areas of the brain can take over the functions of the damaged areas, allowing for partial or even complete recovery of lost abilities. This remarkable recovery is a testament to the brain's resilience and its ability to adapt even after significant injury. Rehabilitation plays a crucial role in stimulating neuroplasticity after stroke. Through intensive therapy, patients can relearn lost skills and regain function. These therapies often involve repetitive movements and tasks that encourage the brain to form new neural connections and pathways to compensate for the damaged ones.